we're doing and kind of some of the things that we're heading for. So check this out. Jeff, if you could dispose of that, I'd appreciate it. So I've written a couple of different functions up here, the graphs. Can you see how only the green one's been graphed?
Yes.
So e to the root x. So I want to do something on both of these that I think in one sense you're going to be like, what? How are you doing that? And that's going to lead us to the, okay, how do you do it? But then also kind of what we're doing today as well. So if you would, what I'm going to do here for this green graph, this will show up, I don't know what color it's going to show up in. I'm going to go ahead and type in, and I don't have this memorized. I just made these up in the last 3 minutes, 4 minutes. Right when Ashley walked in, I just said, let's do these two. They're pretty easy to do. So check this out. Here is the Maclaurin series for y equals e to the root x. There's the first term. 1, right? Okay. There's the next term. Can you see on the graph it's getting better? See how it's getting better? And mind you, oops, that's not what I wanted to do. Let's try that again. Mind you, all I'm really doing here, I'm just typing stuff in. Can you see how I'm not calculating anything? Can you see that I don't have any cheat notes written up here? I'm just doing this in my head, and it's not because I'm so great at this. I just know how to do it real quick. That's it. And you will soon too. It's not the end of the world. So check this out. Getting better, right? Getting even better. So have you guys noticed, as I've typed in these terms, I hope you've been paying attention to each little step, because have you noticed how it seems like the red graph is coinciding with the green graph better and better and better? At least the visual interval of convergence seems to be going from this to this to this to this to this, right? If I had one more term on there, that's what I was thinking.
X to the 2.5.
X to the 2.5. Oh boy, what happened there? To the 2.5 over
120.
120. Wow, I mean, it's so close. I mean, you might be able to still see a smidge of green in there. That's really, really close. So after just 6 terms, it seems like at least visually the interval of convergence from this to this to this to this. Now it's off the screen. Of course, we could do some zooming out and start to see, well, the further you zoom out, you can see that there's some error. But if you go back with my original, yeah, let's go there. Nobody needs to know. That's right. So guys, the idea of how can you come up with this so fast, it's the concept of substitution. And we'll get to that in the next 4 or 5 days. We'll get to it a lot in the next 4 or 5 days. I thought I'd show you this other one here too. Please keep in mind that with this green and red graph, the more terms I added, it seemed like that interval of convergence got bigger and bigger and bigger. Maybe you'll notice something a little bit different with this one. So here is this other graph, 1 over 1 plus x squared. I hope you're getting familiar with this. It looks like the little hill, the mountain. The integral, the antiderivative of this is actually what? What's the antiderivative of 1 over 1 plus x squared? Not tangent. Arctan of x. That's right. Okay, so here's the power series for that. Okay, there's first 2 terms. Looking pretty good, right? Okay, now I want you to pay attention, guys, to this. Pay attention to that part. So, so at this stage I've got 7 terms, so I got even more terms on this one, right? And did you notice how at least visually, the interval of convergence basically was tight? It might have moved out just a tiny bit, but not nearly as dramatic as with that other set of graphs, right? So, any guesses as to why the first set that I showed you, interval of convergence, seemed to like really grow pretty quickly, but then this one not so much? Any ideas why that would be? Okay, so yeah, clearly the first one had factorials in the denominator, right? 2 factorial, 3 factorial, so on and so forth. What else? Go back to the foundation of where these came from. So let me ask you this.
Oh, I get it.
What do you think?
I mean, Alex just told me.
What is it, Alex?
I said it was alternating.
So yeah, the first one is clearly alternating, right? Seems pretty obvious. Second one is not. Agreed there. Look at the red graph, the current red graph, and look at the function that produced it. What does that remind you of? If you integrated it, sure, and that's actually going to be a pretty important thing to think about. But if you didn't integrate it, what does 1 over 1 plus x squared? It doesn't look exactly like the thing I want you to see. Say again?
1 over x squared.
Okay, sure. Like if you just add the 1 in there, but there's a connection I want you to make back to something that
The pi?
a couple days ago, the pi. Oh, like
The areas.
if you do the area from negative infinity to infinity is pi. Now you're thinking even further back than I thought you guys were. I'm thinking like last week. That's true, and that's a cool connection. But you went way back. Something about last week. This 1 over 1 plus x squared sort of kind of looks like something we made a cool connection with last week.
The E thing?
The E thing. What do you mean by the E thing?
Oh, is it this thing where
Oh, okay. So what kind of a function is that, Brandon? The one that just does negative 1 to 1? Oh no, not on your paper. It's not.
Wait, what?
Better not be.
Oh, it's a geometric.
Oh, there it is. It's geometric. So check this out. This series, this red one, is actually based on, I'll just put it like this. It's based on 1 over 1 minus x. And as we talked about last week, 1 over 1 minus x is a geometric series, or geometric function, if you will. And it only converges to a real number if x is between negative 1 and 1, right? Yes? What would I need to do to that 1 over 1 minus x to make it look like the 1 over 1 plus x squared? What would need to happen?
Conjugate.
No. Because if I multiply the bottom by something, I have to multiply the top by something. I'm asking, yeah, what would, like, if I started off with 1 over 1 minus x, what legitimate algebra strategy would I need to take to turn it into 1 over 1 plus x squared? No, because you can't just you can't square the top and square the bottom, and even if you did, you'd get something radically different than what we have, right? You can't just say squared and squared. That changed the value completely, right? I said it earlier with this one, and maybe I'm getting a little too far ahead of myself, perhaps. Would you guys think about it like this? That's a good thought, and we will do that. Would you guys agree with me from before? Hopefully this is a series you're starting, if not already, to memorize. Would you guys agree with this? As long as n just keeps going on forever. You with me? Okay. So, and this might be the part that's maybe a little bit, oops, that's not what I wanted to do. This might be the part that maybe I'm taking too big of a leap here, I don't know. But what could I replace this with in order to get that series off to the, in order to get that expression off to the left? Not x squared, but you're really close.
1.
Not that either. What would I need to replace the x with so that I'd end up with 1 over 1 plus x squared? Negative x squared, right? Negative x squared. And you guys realize You can't do that unless you replace all of the x's with negative x squared, right? That's the idea of substitution. Like, you're allowed to substitute something in for an x as long as you do it for all of the x's, not just like some of them or just one of them. So all I really did to get this is I took this, and wherever I saw an x, I plugged in negative x squared. And obviously simplified a little bit, right? Regardless, though, this interval of convergence, even, it's based on a geometric series. That interval of convergence never, and frankly never will, escape out of this negative 1-to-1 domain. It'll never be able to move past it, because in order to converge to the actual function's value, the x has to be between negative 1 and 1, because we're talking about a geometric pattern here. The question we're going to discuss today is, if I did continue on and I had like billions of terms, took us all week to get all these terms, we still weren't done, right? If that were the case, then this would have inched out a little further, be really close, maybe even be hard to see visually or something like that. The question we're going to address today is, does that approximation, like the series, does it ever actually get to either one or both of the endpoints or not? Or will it always just sort of like get closer and closer and closer? Or does it ever have the potential, as number of terms goes towards infinity, does it ever have the potential to actually get there? Sometimes the answer will be yes, and sometimes the answer will be no. We're going to investigate how to do that. Make sense? Mm-hmm. Good news is you're equipped to do it. You've got all the skills and tools that you need to do that. Okay, so grab your notes. We're in 9-8. We're in power series right now. And it's right here. Here. Okay. So I want to do, golly, you know what? I'll do this first one with you. We'll kind of explore this one together. You might need a little help with number 5. You might not. We'll just see. I'm okay either way. So let's look at number 4 together. Okay, so number 4 says find the interval of convergence. It doesn't say find the radius, although finding the radius of convergence is a step along the way. To finding the interval of convergence, we're going to take it all the way through and consider everything, including the endpoints, about the interval of convergence. So let's see here. Let me give myself a little bit more room here. If you are of the type of person that writes in 3/4 inch tall numbers and letters, you might want to size those down a tad for this, just to make sure that you can get stuff fit in there that you need to. Okay, so here we go. The first thing I need to do if I'm going to find the interval of convergence is I've got to find the radius of convergence, and it might also be helpful to understand the centering point. What would you guys say is the centering point for this particular power series?
0.
It is 0. It is 0. To find the radius of convergence, I need to use a particular method, a particular test. What is the test that we use to find that radius of convergence? Ratio test. So if you're trying to find the radius of convergence or the interval of convergence, always start off with that ratio test. Here's what it would look like here. Limit as n heads towards infinity of the n plus 1th term divided by the nth term, also known as multiplied by the reciprocal of the nth term. And in order for the ratio test to show or reveal convergence, this limit needs to have what relationship with a certain number? What is it?
1.
Say again? No. I just want to know, like, if I calculate this limit, it should be smaller than 1, equal to 1, or bigger than 1. And if we're looking for the interval of convergence, we want it to be less than 1. So I'm going to set it up to be this. Right? We're not looking for the interval of divergence or the interval of inconclusivity. We're looking for the interval of convergence. So we want this to be less than 1. So let's see here. There is a little bit of simplifying we could do. The x to the n plus 1 over x to the n would simplify to be what?
X.
I'm looking at these two right here. If you're dividing like bases, what do you do with your exponents?
Just X.
you're dividing like bases, what do? Subtract. N plus 1 minus n is just 1, so it would just be an x. So it'd be x to the first, or just x. And I'll just write it out like this, n over n plus 1. Now keep in mind, the limit does not apply to the x at all. It applies to n's. So the limit is n heads towards infinity of n over n plus 1. Please, for goodness sake, don't do a L'Hopital's rule here. Just use the pre-calc trick. You can do a L'Hopital's rule, but if you're going to do L'Hopital's rule, you got to do it right. You can't just say, oh, I did some stuff, and you can just say that limit equals what? 1, and therefore 1x, right? So I would go straight to here. Absolute value of x is less than 1. Can anybody tell me what the radius of convergence is at this point?
1.
It's 1. And what's the centering point? 0. So I'm going to show you a little trick that will reveal this, but you probably could have got to where I'm going to go a different way as well. Do you guys remember the way that you solve an absolute value inequality is to do two cases, basically. What you do is I would write x is less than 1. So the first case, you simply drop the absolute value. This is supposing that the x is positive. And then supposing that the x was negative, it would be x is greater than negative 1. So you can kind of see this interval taking shape. I'm going to come up here. Negative 1 is less than x, which is less than 1. My centering point is at 0. My radius is 1. And I've put some question marks over there because there's one thing I don't know. Is it going to be less than, or is it going to be less than or equal to? And on the other one, is it just going to be less than, or is it going to be less than or equal to? Does that make sense? So I haven't decided if there's going to be an or equal to there or not. In other words, like I showed you on the graph, I don't know if the polynomial is going to expand all the way to the endpoints and include either one or both of the endpoints, or neither of them. I don't know that yet. So that's why I put the question marks. All right, so the good news is you're totally equipped to do this. Check this out. I'm going to consider both cases. I'm going to say for x equals negative 1. So in other words, considering the left endpoint first. Here's what the series would look like. The power series would be sigma from 1 to infinity. And I'm just going to replace the x with the left endpoint. So it would be negative 1 to the n over n. Now it is my hope, and perhaps your hope as well, that you would look at something like that and hopefully very quickly recognize that that power series is what kind of a series? It's alternating and harmonic. It's an alternating harmonic. And hopefully you know that alternating harmonics always converge. Conditionally, true. But the alternating element is in there. It's not gone. So what I would say is that series is an alternating harmonic. Therefore, it converges. So what I've just shown here is that the left endpoint is included. So we'll keep that in mind for our final answer. I've also got to consider the right endpoint. For x equals positive 1, it'd be sigma, and then I just replace the x with a 1, right, because I'm considering the right endpoint. So it'd be 1 to the n over n. And again, the hope here is that you would recognize that this particular series has a name. It is a harmonic, which always diverges. So I'd say is a harmonic series, therefore it diverges. So I've shown at this point now that although we get convergence at the left endpoint, in other words, the graph goes all the way and includes the left endpoint, it does not do so at the right endpoint. So my final interval of convergence is in a lovely purple up here. It would be negative 1 is less than or equal to x, which is less than 1. It includes the left endpoint, but not the right endpoint. Nick?
Sorry about that. What if the input was negative 1 and 2? What would the radius be?
Say one more time.
If it was negative 1 and 2 for the
It-
input, what would the radius be? Or would that vary?
So negative 1 and 2, the radius would have to be 1.5, and the centering point would have to be 0.5.
So you add them up and then.
Yeah, but you would have seen some evidence of that. Like, for instance, if that were the case, this would not have been x. It would have been x minus 0.5. We would have known right away the centering point was at 0.5. And then there would have to be some other numbers in there, too, that would eventually end up going to that 1.5 radius. So there have to be like a 3 and a 2 in there somewhere that would get us to that point. The nature, we might be able to make that happen with this sort of setup. We may have to think about that. Yeah, actually, it could have. It could have worked out. If we had the 3 and the 2 in a strategic spot, there'd be some other important differences like the centering point. Good question. Anybody else? Definitely not off topic. That's on topic. Anybody else? Questions?
I have a really off-topic question.
Let's not do that. All right. So I don't know how number 2 is going to go, or number 5 is going to go for you. It might go great. We'll see. There's a little more to it. Why don't you guys try to do a similar type of activity with number 5, finding the interval of convergence. I'm going to do a little bit of work up here and kind of catch up to you guys. Feel free to look and consider. So if you're looking for kind of a basic starting setup, hopefully that'd be a good one. There's the simplified version after some cancelings and such. You guys figure out pretty quickly that the limit as n goes towards infinity. Doesn't even matter, does it?
No.
So at this point, we could just say that. Stop there for the moment. So double check. Look at what I've got. Look at what you have. So you could approach this from a couple different ways. If you wanted to, you could look at something like this and say the centering point's -1 and the radius is 2. And you could just jump to this and say, all right, well, if the centering point is 1 and I go right 2 and -1, I should say, and I go right 2 and I go left 2, wouldn't it be -3 to 1? You could also do it more analytically. I don't know, maybe you didn't look like you need that. I can if you'd like, let me know. But I don't know about the convergence or divergence at the endpoints. So for the left endpoint, x equals -3, I get sigma. It's -1 to the n times -2 to the n over 2 to the n. Kind of interesting, right? So the top really just ends up being sigma of 2 to the n over 2 to the n, which is just 1 to the n, right? Hello? Yes? What happens with that? Say again, what's... Okay, you could say, yeah, common ratio is 1, which is right on the border, right? Or you could say that the nth term test headed us towards 1, which isn't 0. So you could say that this diverges, and I think I like Colin's idea because you can say it's geometric and r equals 1, which is not... So you could say, therefore, absolute value of r is not less than 1. You could do the nth term test saying the nth term does not head towards 0. Yeah, there's a variety of ways you could do that one. And did you guys get a similar looking thing for the other endpoint? Should be. So this one, these just cancel out. diverges because something like that. So in the end, with this one, your final answer in red would just be the open interval on both
Got it
endpoints.
right, Josh. The first time. You didn't correct me.
So, hey, so again, I want you to understand with, things like endpoint analysis, it's binary. It's either open or a closed interval. And so really the main thing is your presentation of why I chose what I chose. Yes, ma'am.
So if it's just find the radius of convergence, you would leave it at x plus 1. is
Stop
like
right
plus-
there. You'd say the radius is 2 and you're done.
Okay.
Yep.
And then if it's interval, you would go to the other.
The only extra step with interval is you got to consider the endpoints. Yep. Dylan.
So I don't understand where the centering point came from and where the radius came from.
Centering point came from right there. Remember with your Taylor series? Taylor series is f of 0 times f prime of 0. Let me reverse. Let me rewind. That's at 0. Let's move it off 0. Wouldn't a Taylor series be f of c times f prime of c times x minus c plus f double prime of c times x minus c squared over 2 factorial? Does that ring a bell? Okay, so you need to go back and look at 9.7. Maybe rewatch the intro video. Look at your basic Taylor construction. What goes along with all the variables is the centering point. It's always going to be x minus the centering point. So for the previous one, number 4, did you see how it was just x to the n? We could comfortably say that that's x minus 0. Here, it's definitely not x minus 0. It's clearly x plus 1. So it's really x minus negative 1. So when you look at your variable in your nth term, that's always going to show you the centering point. If there's no number with the x, the centering point's 0. If there is, then you know just the opposite of that number would be your centering point. Radius comes from this down here. We're basically saying with this, we're saying for what x values, this is I'm overgeneralizing a little bit. We're basically saying for what x values do we get convergence? And we do our simplifying, we come down here, we finally do our limit, which of course in this case we didn't even have an end to do a limit to. And we found that if the absolute value of x plus 1 over 2 is less than 1, we'll get convergence. So all I did, of course, is I just multiplied the 2 over. 1 times 2 is 2. This tells me that as long as the absolute value of x plus 1 is less than 2, I get convergence. So that's like me telling my son, as long as you're standing within 5 feet of this rock, you're safe. I've given him a radius, haven't I? We've basically told this series you have a radius. As long as x plus 1 stays within about 2 feet of this centering area,
So do you need to get,
we're good.
Do you need to get x plus 1, whatever that,
Yeah,
you need to match it up?
you need to isolate that.
Okay.
Could be an x plus 1, could be an x minus 9, could just be an x. That's just going to depend on if there's a centering point that's 0 or something other than 0.
Makes sense.
Okay, so let's see if you can recognize this next one. If you recognize it, this could go by fast. If you don't, it might take you a few more minutes. This will be our last one for the day, and it's number 6.
Well, Josh is fine. Wait, Josh.
Find the interval of convergence for sigma x to the n. Anybody recognize what kind of series this is?
McLaren.
Yes. Even more specifically, it's got a name.
Geometric.
It's the geometric series. That's right. So this can certainly be proven. We've sort of proved something really similar to this a few minutes ago. Hopefully you would end up with, after you did your ratio test, you'd end up with this, which means your radius was it what? And what's the centering point for this series? 0. So you'd go here, and you'd say, all right, well, I'm not sure about those endpoints. You'd analyze both endpoints, and you would get divergence, right, at both endpoints. So your final interval of convergence would be this. I was hoping that you would recognize this is a geometric series. I know what it is. I keep on asking you, do you recognize this? Do you recognize this? I'll tell you, your ability to recognize stuff like this, with even in disguise, is going to be really helpful for you moving forward. So that's why I've asked you a lot, and you've already seen this quite a bit. So hopefully you'll continue to internalize. Yes?
On this one, the fact that it's geometric is enough justification.
Well, so I was pretty vague about this. I didn't say show the steps leading to your answer, justify. If I want to see those, I darn well better see a limit with the ratio test. I better see endpoint analysis.
Yeah.
I just left it open because I didn't know if you'd recognize it or not.
Okay.
And if you didn't, you probably went through all the endpoint analysis and stuff. So just pay close attention to show the steps, justify your answer, that kind of thing. And this is all like what I wrote up here is just kind of chicken scratchy stuff, just hoping that you recognized it. Please don't look at this and think of it as a model for what you should be doing. I've shown you that plenty of times.
Yeah.
So to like adopt this would be like, I know you showed me correctly 30 other times, but you showed me this one time, so I'm going to go with that. No, this is not your model.
It was from the board once, so.
I know, yes.
that means I'm right.
That's right. Incorrect. Yes, ma'am.
If we were to do this in the AP test, would we like write the question mark too?
I like that just because it shows you're in process, right? So, like if you didn't write the question marks, think of it like this. If you didn't write the question marks, and then later on you wrote this, and maybe you didn't write the box around this, or something, this is confusing because you're telling me two different things are the answer, more or less. But if you come up here and you do this, you're saying, well, I don't quite know about those yet. And then somewhere else, you're like, now I do. You're telling me you're in process. I think we're all okay with that. We understand it takes a little time to get to the end. Okay. The only other thing here worth mentioning, I suppose, is that down below you can see these four that I've mentioned in the past. Here they are. I don't think there's any typos. Look, they look good. They all look pretty good. Yeah. These are the four series, along with the nth terms, that you need to be thoroughly familiar with, to the point when you see it, you don't have to really do that much thinking. You just instantly know, oh, it's that. Because in the next 5 days, the main thing we're going to be doing is starting there and using those, kind of like I did at the very start of our class. Yes, ma'am.
So next Monday, would it be just us for the topics?
It's all of the non-seniors. I have kind of budgeted for that more or less with the time. Alex, there you go.
Hey, thank you.
I've more or less budgeted for the time for that, but we'll continue to discuss. It'll be a pretty like less formal scenario.
You better shout out.
I was telling these out this morning. You can see that I subtracted that. Here you go, Brandon. Your grade is going to be accurate. It should be 32.5. Sorry. Here you go, Jeff. Come on. Here you go. Come on. There you go. There you go.
What? I tried. I did. I take
Colby. So there's a lot of technical things on here. A lot of little technical things. E sub n. So it's just too yourself. Then you do the window.
Because, like,
You know, like, it
when
just
I check
sloppy,
my
right?
answers,
So like down
I
here,
like, if I
you
just
put
look
this to
over it,
this,
I
and
would
then it
actually
should
say
say
I would wrong. So I'll like redo the problems and then
It'd
I'll
be
like
easier to
compare.
say.
Have you done that
this equals
using
that.
test or quiz?
Whenever I have time, and then,
I think this is pretty non-standard.
You forgot
You can equate
to
some
mention
sometimes,
the.
call it that, use that correctly. So, yeah, based on you writing this contradicts that instantly, right? It's not very precise. So, yeah, this to me is just sort of like, this would be your bigger thing, your positivity for the comparisons. Yeah, just be careful with how you note things.
Oh, yes, okay,
I
so.
thought that one answer, I get why number
Best
three
you
doesn't
can,
have
try not to
to
do
be
the.
showing you how.
Okay, so.
I get it. Try to think ahead, like think to yourself.
You
Start
know
off
that
by
number one.
thinking, I don't have enough space to do this. I'll start high and tight and write small. And then you get to
So
the
for
end,
number
like, oh,
two,
well,
I would recommend doing the limit comparison test.
Oh, well.
So divide k squared over
I
k
did my best to
equals
follow it. I
one.
think that I
Divide
more or
it by
less did.
1 over k squared. You now get k
But,
squared over k
like when you've got like
equals
two
1.
different
You take
series
the
going
limit
on,
of that,
ace events,
which
ace
now
events,
equals
all over the place, it's like, whoa. I had a couple times I sit on my cups, and a couple times
which now
that's
equals
worse,
1,
I just
which
have
is
to
finite and positive.
maybe just sit back
And you know
close
that
my
1
eyes.
over k squared is equal.
I didn't take a break from the
Therefore,
maze.
k squared
And then
over k
I'll look at
equals
it.
1 also.
So,
Okay.
And that one is absolutely accurate.
right, you're off by one on your count.
See, I thought.
You shouldn't have.
Like I said, these are, with the answer to all of these on these first couple of quizzes, the answer's have always been, well, that's divergent conversion, or, you know, errorville, like, that's it. So all of the details, all of them.
You use, because you never said that.
Yes.
Yeah, yeah, I'm like, wait, what was that?
We don't.
You still have to
I knew everything.
Yes, I suppose that they are. And we have to prove them. So you did it right here.
Yeah, that's what I did.
I would favor right?
That's because it was so much less. I also did it here. In which you got the square.
I literally
Therefore, if I put that back in, I'm guessing
He was so expressive the entire time. Half the time his face
you
is
just
just
basically
He's so
my own extension is strange, but then you want to keep going.
Oh.
Or like at the one scene where they're at the table and he like got stood up by Dorothy.
You know, I'm in that scene too.
Yeah, but
I was supposed to do the limit.
You use, like, this is interesting.
That's the whole point of this character.
Here's how I
You know
write
the one,
this is a ratio.
like the one pose that you guys do at the end of that scene where you're like, I got a really good picture.
Can you only do the maximum area on his
That's the three.
Okay, so here's the issue. You did not attack
Tanny, what are you arguing?
like, if you didn't like this.
It doesn't equal 0, and that's the answer.
Oh, I also got documentation. Get that right now. Yeah, see, I also.
I was thinking about raising it.
Well, actually, I did it backwards.
Because I didn't draw it.
Why is the that's why I figured out that
Six over 6.
I got that part, but he still forgot that. What I did, That's the same.
One over here.
You guys need to go, I'll click these on the way out. Is, you just get two seemingly sort of kind of rival stations. Like, this is a file that, this is the natural state. And so the issue is, you showed me like a valid entity incorrectly done. And then you showed me a whole other correct. So this was a 1 out of 3. I think we're only two. I didn't calculate that out correctly. Well, here, this is right. So this is a 1 out of 3. Thank you. This is a 1 out of 3.
I'll see you later. What are we supposed to do before? Please don't forget, I get your book.
Yeah. Like, I just feel that it was the right thing, but then I didn't say that that.
Yeah, I'll give it to you.
Like on this one, I said 3 conditions for an issue, but well, and the fact that it, on everything you wanted to explain how the conditions were met, I was like freaking out and just like writing stuff. Like, really write it.
I just set up a meeting last night and forgot.
Exactly. Yes. We have less than 90 days left.
This is really sad.
Please know that I'm the only temporary.
Wow. So this way, that's the only, like, that's the school that's like, you know, sort of required to take, you need, like, once you have your types of promotion, you just go.
You gotta learn. Next question,
You don't have to go.
Yeah, we have to within 90 days. Like a lot of
Area is
people.
huger. Yeah. Thank you. Yeah. That's right. Thank you. Yes. Thank you.
Hi.
Graphic designing it up.
You're telling me that.
Would you like to darkroom it up
So these
instead?
just have to be.
Can
true.
we?
So when you say that this is positive.
We're
and this is
farther along than the whole rest of the class.
See, I don't get how we're so much farther along. I just think.
Just better.
I don't know. I feel like whenever Mr. G isn't actively watching them, they are not doing it.
Okay, that makes sense. I'm like, it makes me feel like we're just doing like too easy of stuff and it stresses me.
No, we're not. Our designs are the best.
Because if we move off of one week, like if we were, I think,
Thank you.
if we went into some negative numbers.
Yeah, I get that. I just didn't know. Like, I don't. What am I saying when
The way that I read that, you're telling me that it's divergent.
What'd you do to Ashley?
He threw a
Nothing.
penny in his skin.
The original.
Alex.
It didn't hit me. It hit the wall.
Yeah, but I'm still mad at you.
No, it's okay. It was funny enough. It just scared me.
Because I'm like, I don't know.
Okay, I'll see you over there. Yeah, I
And then when I was checking to see, like, oh, do I need to make sure this? And I don't know. Didn't write that down.
No, I took them all off. And I needed to, because I was, I really, I told myself that if I was doing
Because I got a class coming in.
any
Just
time
1 minute.
in the dark room, I was gonna make a screen.
Tell me what it is. Be
For
specific.
screen print.
So sometimes you can't be specific. There was one thing we did today where.
Wait, let me see the
I love it.
That is the important. That is the
Yeah, what do you want?
But be specific. Be as specific.
Oh, she actually is gonna try this thing.
Starts at 0. So if partial sum equals 3, this is n equals 3 right here. So you gotta go 1. So if you write this as sigma from 1 to infinity, this is 0. Thank you guys. Thank you. Okay, sounds good. What's up, guys?
I did. Darker, very graphic design. If I can convince me.
Saggy B. I was like, no.
So much or red. So I will say this. I'm of the opinion that I will sometimes in these situations maybe give people one mulligan. This is your mulligan. If you show up to something like this in April, I'm like, I'm behind again and I'm screwed or whatever, the answer is going to be like, I'm sorry, deal with it. Right? April is going to be way more intense than summer now. If that's the deal, you need to step up and make sure that happens, but it cannot be much. Because I have one opportunity to eat. And I have to eat lunch, even for 10 minutes. Right? So, this is one of those situations I'll leave the ball in your court. I'm not going to tackle you and like, force you, but let me just say, I hate this. I hate a situation like you show up at the moment of, you're like, I can't do it. You put me in an impossible situation, because now everyone is staring at us, and now I have the opportunity to look like the nice guy, or I could be the mean guy, or whatever. Like, this is a really bad situation to put me in, and I don't like it. I wish that you would not do this. If you would have emailed me last night, I would feel differently. You put me in an impossible situation. I think that's not nice. I think you should do better. I think you should do a lot better than that. That makes sense? So, you do what you're going to do. I have no control. I can't really make you do anything. But I can tell you I don't appreciate I know it's the moment of the quiz right now, and now we're using everybody else's time to have this discussion.
This morning, so.
Right? So, do what you need to do, but just realize, not really acceptable. Not cool. But I will make room for you in red if you want to be with a bunch of freshmen. Pick your poison. Yes, please. Yes. Yes, please. I'm not telling you what you have to do. Don't read me wrong. Don't read me wrong.